Hello guys, in this video I'll try to make you understand about insertion sort and its algorithm. So, we're gonna study about working of insertion sort and its algorithm. So let's begin. So, uh, working of insertion sort. First of all, we have to take an array. So let us take an array. Let's say this is an array ARR. Let's take 12, 11, random 5, 13, 6. So we have taken an array. So how it works, we have to understand it. So we have 12, 11, 5, 13, 6. In insertion sort, we have to compare the adjacent elements. Like we have to compare 12 and 12 to 11. If it is in decreasing order, then we have to swap these elements. If it is in increasing order, we have to leave it as it is. So let's start. So we have the first pass. So we have the array 12, 11, 5, 13, 6. Let us compare these two adjacent elements. These two elements are in decreasing order, so we have to swap it. So we got 11, 12, 5, 13, 6. The first pass we have completed successfully. Let's move to second pass. Now in first pass we have compared these two elements, then move to next two elements, that is 11, 12, 5, 13, 6. The next two elements are 12 and 5. Let's compare. So these two elements are in decreasing order, so we have to make it in increasing order by swapping them. So we have to swap them. Now the array looks like this: 11, 5, 12, 13, 6. Now we can't move to 12 and 13, because after swapping we have to check these elements, check these two elements if they are in increasing order or in decreasing order. If they are in increasing order, we have to leave it as it is, or if they are in decreasing order, we have to swap them. So we have to compare these two elements, 5 and 11. So they are in decreasing order, we have to swap them. So we got 5, 11, 12, 13, 6. Now the second pass is successfully completed. Now let's move to third pass. This is 5, 11, 12, 13, 6. Now we have to compare 12 and 13. These two elements are already in increasing order, so no need to swap them, so leave it as it is. So the array looks like now this. The third pass we have successfully completed. Now let's move to fourth pass. 5, 11, 12, 13, 6. So we have to compare these two elements. These are in decreasing order, so we have to swap them, and the array looks like this. And we have to, and here 6, 12 and 6 are in decreasing order, we have to also swap them. This looks like this. And here also 6 and 11 and 6 are also in decreasing order, so we have to make them in increasing order by swapping them. So we have 5, 6, 11, 12 and 13. So now the array is sorted. So now the array is successfully sorted. Now let's move to the algorithm part. Algorithm of insertion sort. So let's take the same array, and we have to find the algorithm, or to write the algorithm of that. 12, 11, 5, 13, 6. So let's take these elements are these elements is I, and these elements as j. So when we will do the insertion sort, we have to move the j uh, to from index 1 to 6, 1 to 0, 1 2 3 4, 1 to 4, and index I to from 0 to 4. So we have to run a for loop for that. For j equals to 1 to 0, 1 2 3 4 to 4, let's say a dot length. Let's take this array as a, and so we have taken a for loop for j equals to 1 to a dot length, and let's take another variable called key, where we store a of j, and I will be j minus 1. It is obvious, because if j is this, so I is just the decreasing order. So while a of I is greater than key, that means a of I is greater than key. Key is this much. This element is key, because we have taken a of j equals to key, so this will be key. While I greater than key, we have to swap them. So we have to write the swapping formula here. A of I plus 1 equals to a of I. That means a of I plus 1 is 11. A of I equals to 12. So 12 will be assigned to 11, and we have to decrement the I equals to I minus 1. And now a of I plus 1, that means we have decremented a of I plus 1. If a of I plus 1 equals to k. So let us understand this algorithm. So we have taken a for loop from j equals to 1 to 4, and we have taken a variable key that stores a of j, that is a of j here is 11. So 11 will be assigned to key, and we have again made I equals to j minus 1. So the index of j is 1, so I equals to 1 minus 1 equals to 0. So I is 0. So again we have taken a while loop. While a of I greater than key, that means a of I is 12, a of 0, I equals to 0, so a of 0 equals to 12, while is greater than key's value is 11. So while 12 greater than 11, we have to do a of I plus 1. That means I equals to 0. That means a of I plus 1 is a of 1, that is 11, is equals to a of I, that is 12. So 11 equals to 12. That means 12 will be assigned to 11. Now we have done I equals to I minus 1, that is 0 equals to 0 minus 1 minus 1. So we made I equals to minus 1. Now a of I plus 1 equals to key. That means a of I plus 1, that is a of minus 1 plus 1, that is a of 0. That means 12 equals to key. That key is 11. So 11 will be assigned to 12. So this total process we have done to swap 12 and 11. So that's how it works. Now the for loop will move j equals to 2. So this will be j, and I will be j minus 1. So this will be again I. So that's how it will be continued, and eventually we will get the result. We'll get the sorted array by insertion sort. So thank you very much. If you like this video, then like this video, and if you want this type of more video from selection sort or bubble sort from any sorting algorithm, please let me know in the comment. I'll make a separate video on them. So please like, share and subscribe, and don't forget to comment on this video if you find this video helpful. Thank you very much.